Hi, have you ever wondered why blood pressure is measured in height of some fluid? Generally, if you visit any doctor, the blood pressure is told in terms of of mercury, or simply they say 120/80. It is not just a number, it should be always associated with of mercury. It can also be told in terms of of other fluid. We will learn that in this class. The device which is used to measure the blood pressure is called as sphygmomanometer. Okay. Now, sphygmomanometer is essentially having a mercury column, an air bulb, and we must have an inflatable cuff. Now, let us look at how this sphygmomanometer looks like. Now, it has got a cuff which is inflatable, a rubber bulb which is used to inflate this cuff, and we have a mercury column, and very important, we must have a stethoscope. And remember, we are trying to measure the blood pressure of heart. Let us say heart is here, and there are arteries coming from here to this side, and we have been practicing that. We can also see the pulses here. The idea is we must inflate this cuff to an extent where the blood flow stops to the other side. So, we will not have any pulse. So, when do you think you can stop this flow? If you increase the pressure in this cup so much that it is greater than the pressure exerted by the heart, correct? So, that is what we call this. This is exerting a pressure on these arteries, and if you inflate the cuff greater than to this pressure, there is no flow through these arteries. So, on the other hand, we will not see the pulse. Now, there will be a releasing valve in this cuff, and you must see that whatever that pressure equivalent to that pressure, we will have the height of mercury which is coming up here. So, if we increase the pressure greater than the pressure exerted by the heart, this is our first step. Then what we shall do? There is no flow now. When do we think that the flow will start? If we start releasing this valve, the point where the flow start is when the pressure exerted by the heart is just equal or just a bit lesser than the pressure which is exerted by the cuff. So, that is when the flow starts. So, when pressure is equal to the pressure of heart, the flow of blood starts. So, when we did greater than the pressure of heart, the flow was stopped. There was no pulse. And later, when we start releasing the valve, we see that the flow starts when the pressure is just equal to the heart. That is when we measure the height of this column, and we say that that is systolic pressure. Now, systolic pressure is the maximum pressure. There are two pressures measured with respect to heart. So, maximum pressure is generally will be 120 of this height, that is mercury. There is other pressure. Now, very important, stethoscope is an integral part, like it is not attached to the sphygmomanometer, but without a stethoscope, it is hard to make when the flow starts. It is, we must hear to the noises which is coming here. So, there is a restricted flow. If you have a pipe and if you try to contract it and there is a fluid flowing inside this pipe, then what we see is that there is a restricted flow. Because of this restricted flow, we see that our turbulent flow, we can hear the noises, or tapping sound, or cartac sound, we call it as. So, we can hear that in a stethoscope. So, we must note down this height when this sound starts appearing in the other side of the vein. Now, when do you think this restricted flow will stop, or when do you think the noise in coming out of this will stop? That will stop on the, if you start releasing this valve. So there is a point when there is no restriction at all. So that is the other pressure, we call it as diastolic pressure. That is the other pressure, we call it as diastolic pressure. So this is when no restricted flow. So this is measured when the tapping sound or restricted flow stopped. So this is what we call it as diastolic pressure, and this is generally 80 mm of mercury. Now let us answer this question. In engineering, we write the pressure in Newton per meter square, but when we come here to the blood pressure, we are talking in terms of mm of mercury. Okay. Now, height of fluid, but we want it in Newton per meter square. Now remember, pressure exerted by the fluid because of its weight, we give it a formula rho g h. For example, if we have a column, and we have water in it, let us say, do we get the pressure here? Because of the weight of the fluid, all right? Because of the weight of the fluid. That is given by rho multiplied by g multiplied by h. Okay. Now, here also we are talking about 120 mm of Hg. So, we will use the same formula, P is equal to rho gh. Let us try to convert the unit first. Density should be kg per meter cube. Gravity, acceleration due to gravity, meter per second square, and height is in meter. And this kg multiplied by meter per second square is mass into acceleration, which is Newton. And this meter goes off with this meter cube, will have Newton per meter square. So, in order to get the appropriate unit of Newton per meter square, we must substitute density in kg per meter cube, gravity in meter per second square, and height of the fluid in meter. Now, let us convert this 120 mm of Hg. So, density of mercury is 13,600 kg per meter cube. Now, this is density of mercury, because we are talking in terms of millimeters of mercury. So, mercury is the fluid. Acceleration due to gravity, we know it is 9.81 meter per second square, and height, which we are talking 120 mm, so but we want to write it in terms of meter. Now, we have converted that into meters. So, let us say P is equal to 13,600 rho, gravity is 9.81, and height is 120 into 10 power minus 30. Now, 13,600 multiplied by 9.81 into 120 10 power minus 3. So, 16,009.92 Newton per meter square. So, the same pressure 120 mm of Hg can be written in terms of Newton per meter square, and similar is the case of 80 mm of Hg. Okay, and we also represent the pressure of atmosphere as 760 mm of Hg, which is 760 mm of mercury. So again the same trick, but here we are talking about air, but however the pressure which we are talking is mm of mercury. So the formula remains same, P is equal to rho gh. The density is 13,600 of mercury, gravity is 9.81, and we are talking about 760 into 10 power minus 3 because we want to represent it in terms of meter. 13,600 multiplied by 9.81 into 760 into 10 power minus 3. This is what we see, 101396.6 Newton per meter square. So we always remember atmospheric pressure, right? So 1.01325 bar. So that is what this value is. So atmospheric pressure is close to 1 bar. Or you can also represent the pressure in terms of height of some fluid. Now can we convert this in other heights of other fluid? Yes, we can. For example, if we have, for example, let us say 120 mm of mercury, blood pressure, if we wish, we can also write this pressure in terms of other fluid. Let us say, can we represent blood pressure in mm of water? All we have to do is rho gh must be equal to rho gh. Now this is, we are interested in height of water, density of water. So this side we have mercury. So for getting the same pressure, what is the height of water? So density of mercury is 13,600. This gravity you can cancel out, however, or if you wish to write, you can write 9.81. Now height of mercury is 120 into 10 power minus 3. 120 into 10 power minus 3. On the other hand, we want to write it in water. So density of water is 1000. 9.81 here and height of water. Now this 9.81, 9.81 goes off. 13,600 into 120 into 10 power minus 3. So this is on the left side, and if you divide by 1000, you will have the answer. 1632 divided by 1000. We have 1.632 meter of water. 1.632 meter of water. So it also gives you an answer why water is not used here, because in order to get the same pressure of 120 mm of Hg, you will use, so that is 1632 mm of water. So in order to get the same pressure, the height of the column which we are using, if we use water, will have to be 1632 mm of mm. So that means the sphygmomanometer becomes bulkier. That is the reason why we choose mercury as manometer fluid. Okay. Thank you.